All right, so we're back here and basically going to run this circuit and kind of show you guys how to analyze the results. Okay, so first, what I'm going to do is I'm going to label both nets. I'll just call this net V1. It's a pretty good practice to get into the habit of labeling all your nets. I would label this net ground. Typically, this would be my ground net, but what I can also do is I can just place a ground symbol. So let me go ahead and say place ground symbol, and that's just going to be G on the keyboard. So I hit G, and I get a ground symbol, and then I can place some wire to just connect this node to ground. And now if I highlight this net, you see up here it says this node is 0. Okay, so I don't need to name it. It's basically LT Spice just knows that that's the net that I want to be my ground net or my reference net, because all the other voltages and in the circuit are going to be referenced to this 0 volt net. Okay, so if this is at 0, I have a 9 volt source here. I go across my 9 volt source, and then V1 is going to be 9 volts. At least that's what I expect to see. So I want to get ready to run this simulation. For DC circuits, the type of simulation that we want to run is called an operating point simulation. And so to bring up the SPICE directive window, basically the SPICE command window, I click S on the keyboard. So let's just put open SPICE command window, and that's going to be S on my keyboard. So I hit S, and now in this window, I basically can type the I can type the kind of simulation that I want to run. And so I said operating point. It happens to be that I would type .op and hit OK. And now I can place this anywhere in the window. And now LT Spice knows that the kind of simulation that I want to run is an operating point simulation. So for run operating point simulation, I'll just put type .op in SPICE command window. Okay. All right, so we're ready to run this simulation. You see the little icon here with the running man. It says run. So if I hit run, I get this bizarre box here. Interestingly enough, on the Mac, this is what happens. On the Windows, this doesn't happen, but I don't care about this box. What I actually care about is the SPICE error log, okay? And so to open that, I gotta go ahead and hit Command L on my keyboard, and it brings up this little window with this information that I've highlighted here. And basically what an operating point simulation does is it tells me all of the node voltages and all of the branch currents through each component in my entire circuit. Okay? And so it says, you can see the first one, V of V1. So that's the voltage of the node that I labeled V1. Okay, actually, let me label that something else. Let me call it VX just so it's clear that that's what it's referring to. I'll run my sim, close my box, and then again, I want open SPICE error log. That's just what it's called. And I'm going to go with Command L. All right, so I hit Command L. Here's my SPICE error log. And again, it says direct Newton iteration for .op point succeeded. That basically means it ran the simulation properly. And it says operating bias point solution, which is basically just telling me here is what we found, or here's what LT Spice calculated. It calculated the voltage at point VX, or node VX, to be 9 volts, and that's exactly what we expected. It calculates the current through R1 to be 0.0009 amps. Basically, these currents are given in amps. Okay, so if I'm looking at this, I can move my decimal 3 places, and I would have it right here, and it would be 0.9 milliamps, which is exactly what I would expect from 9 volts divided by 10 kiloohms. But then what's interesting is it says that the current through V1 is negative 0.0009 amps, or negative 0.9 milliamps. Why would that be negative? Well, the way that LT Spice defines current flow through a voltage source is it defines it in the direction from plus to minus, okay? And so since I know the current in my circuit is actually flowing clockwise, which is why through the resistor it says that it's 0.9 milliamps, If I were to go this way from minus to plus, I would have 0.9 milliamps. But because LT-Spice defines the current through the battery from plus to minus, it results in a negative current. So similarly, if I were to switch my resistor, if I were to Control R or Command R to rotate my resistor around, let me actually add that here, rotate component, and that's going to be Command R. And then I go ahead and rerun the simulation. Now when I bring up my error log, you can see that both of them are negative, because now we just flipped the way that LT-Spice is defining the current through the resistor as well, okay? We can't flip the voltage source so easily because the voltage source is 9 volts. If I flip it, then I'm going to end up with negative 9 volts here. But one thing we can do, and this is the last thing I'll do in this video because we're getting... Actually, I'll do it in the next video because we're running out of time. This one's getting a little long. But okay, so we just learned how to run a .op simulation. In the next video, I'll show some more stuff about measuring the currents and maybe add some more components.